Alright, so we're going to be looking at finding the composition of a compound. And so this is another type of analysis by mass, and the way that we're going to do this is just by doing an example. So our question is, we have a sample of an unknown organic compound with a mass of 2.203 grams. This was burned in oxygen to form 1.32 grams of water and 3.23 grams of carbon dioxide. We're also told that the molar mass of the compound is known to be 60.0 grams per mole. And here's our question: find the empirical formula and the molecular formula. Alright, so the first thing we need to do is find the empirical formula. We can't find the molecular formula without the empirical formula first. So, hopefully you guys will pick up on the fact that it says it's an organic compound, okay? So an organic compound means we could have a few things in it. We're told we have water and carbon dioxide being formed, so our options are carbon, hydrogen, and oxygen, okay? We're also told some information about the masses of things. We know that the original mass is 2.203 grams, and we have 1.32 grams of water being formed. Okay, so all of our hydrogen in our original organic compound is being converted into water. That's the only other place that the hydrogen is going to. Okay, there's no hydrogen in carbon dioxide, just in water. Okay, so we can work out the amount in mole of water. Okay, so we know that it's going to be mass, obviously, divided by molar mass. Now the mass of water is 1.32 grams, and the molar mass of water is 18.0 grams per mole. Okay, this is going to tell us how many moles of water we have. So that works out to be 0.0733 recurring mole. Okay, now this is telling us something about how many moles of hydrogen we have. For every 1 mole of water, we have 2 moles of hydrogen. Okay, so we can now work that out. So it's going to be how many moles of water, we're timesing it by 2. So we're just going to times by 2 the answer we just got. So double this is going to be 0.14667 moles. Okay, we're just keeping a few decimal places there until we get to the very end of our question. Okay, from this point we can then work out the mass. So when we're doing empirical formulas, we need to find the mass. The mass of hydrogen, therefore, is going to be, remember, here's our equation. So mass is going to be moles times molar mass. So 0.14667 moles times the molar mass of hydrogen, which is 1.0 grams per mole. So the mass is just going to be 0.14667 grams. Okay, so that's hydrogen. Now carbon, we know is being converted into carbon dioxide. We can find out how many moles of carbon dioxide we have. So it's going to be the mass, which was 3.23 grams, divided by the molar mass of carbon dioxide, which is 44.0 grams per mole. Okay, this is telling us how many moles of carbon dioxide, and that is 0.07349 moles. Okay, now all of our carbon is actually being converted into carbon dioxide, so the amount in mole of carbon is going to be the same. It's 1 for 1, 0.07349. We'll continue this in part 2.